It's the AQA AS Maths papers from May 2018. We're on paper 1 and we're looking at question 6, which involves a triangle. When I read this question, I was completely confused as to what on earth they were asking, but it became a little clearer. So, we're told we have a right angle triangle that looks something like this. And we're told that that point is A, that is B, and that is C. D is a point they introduce and say it's a point on the hypotenuse, so it's on AC, such that AD equals AB. So if AD equals AB, that means that that distance there and that distance along that must be the same. So at some point there is the point D. And I'm then told the area of ABD, that triangle there, if I dash a line there to show you there's a triangle there, ABD, is half that of ABC. So the triangle ABD is half the area of the triangle of ABC. So this area in here represents half the total, which is the same as that area there. Let's see if there's a way to, we're then told to show that we're required to show RTS that tan of the angle A is equal to twice sine of the angle A. Let's see what we can do about that then. Right, let's start with tan A, shall we? Let's say that I've got some sides here. Let's label these sides to begin with. Let's call, now I don't want to use A, B, and C. That's going to make things ever more confusing. Let's call AB, that side, let's call that X. And let's call BC Y, just for ease of use. Then I know straight away that tan of A is going to be the opposite over the adjacent, which is Y over X. I'm asked for tan A, may as well write down what tan A is. I'm told that's Y over X. So that's not bad. I also know, using X and Y, I know the area of the triangle ABC. So if I say the triangle ABC, I'm looking at that, and I say the area of that is going to be, well, it's going to be half times base times height. So it's the half times the base of this is going to be X, times the height of it is going to be Y. Let's write it here without the time signs. I shouldn't have written half X, Y. So straight away I have an equation for the area. And you can see that somehow I might be able to incorporate that tan A in there in some way. But let's make a bit more progress somewhere else and then come back to that in a second. But those are two legitimate equations I can write down. Let's now look at triangle ABD. Well, I was told a minute ago that AD is AB. So if that length is X, well, that length must be X as well. And it's easy to think straight away, well, that length must be X as well. I have a lovely equilateral triangle. And I might do, only if A is 60 degrees, of course. If that angle is 60 degrees, and similarly ABD and ADB are 60, then it's equilateral. But I can't be certain of that. I do know, though, that I have an isosceles triangle with two sides being the same length. Let's look at that triangle ABD, and we're doing area. Let's look at that. What's the area of the triangle ABD? Well, I've got two sides, and I'm interested in that angle there called A, and I know the area of that triangle is going to be half AB sine C is what we usually know it as. Half AB sine C is what we call it. I'm quoting it because it's a standard result. What that means is then it's the two sides multiplied by sine of the angle between those two sides. Well, X and X are my two sides, so that's half X times sine of the angle in between becomes sine A. For clarity, this is just quoting a formula. This is actually writing down what it looks like. So that becomes half X squared sine A. So I've got an area of ABC, I've got an area of ABD, and I know that this one, if I were to halve that one, I get that one. So let's see what that's using this up here. So let's use this equation. Should we call that equation 1? And let's bring down equation 1 over here. It tells me that ABD, which is this one, so a half times X squared times sine of A is going to give me half times the area of ABC, which is half xy. That's looking promising now, because I think I can incorporate that in some way and I'll be fine. Get rid of the halves. X squared sine A is a half xy. Let's get rid of the x as well, shall we? They can go away. So now I'm told x times sine A is a half times y. Let's, I'm just looking at what I have. I've got a sine A there, well I need that in a little bit. I've got a y and an x over each other here. I've got an x here, a y on this side. If I divide both sides by x, I'm going to get something I think quite useful. So I now get sine A is a half times y over x. And between this line and this line, I've simply divided by x. The reason I've done that is, well, the question's asking me to work in y over x, because that's what tan A is. So at this point, I've got sine A equals a half y over x. At this point, you can probably guess where I'm going to go, because I compare it to that, and I get sine A. I need to double it. Well, that's good. There's a half there. Let's double both sides and get 2 sine A, and y over x is tan A, so that becomes tan A. And I might write because y over x equals tan A. The reason I wrote that last, let me finish that off firstly, put a nice big box around it. The reason I structure this so carefully, and most importantly add a because as part of it, is kind of when I'm told to show that there's some equation, the examiner must see that I've done all the steps to get there. I haven't taken any jumps, and most importantly, I haven't used the outcome that I'm aiming at as a presumption on the way. I've definitely used it as a target, because that tells me where I should be aiming. There may be many other equations I might be able to derive from this problem. But because I'm aiming there, I know what I'm doing, but at no point have I presumed that in order to get to a position.